Welcome to Uni, What? In this video we will start the chapter Electricity. Let's begin. What is electricity? Electric charge is the source of electricity, a type of energy. The most practical and convenient source of energy is electricity. Given that it is easily transformed into all forms of energy, can be stored, and can be transmitted over long distances with very little wastage. What is an electric charge? Like mass, the charge is the fundamental property of matter. Electric charge is the basic property of matter that governs how the particle is affected by electric or magnetic fields. There are two types of charges. 1. Positive charge. 2. Negative charge. The charge acquired by a glass rod when rubbed with silk is called a positive charge, and the charge acquired by an ebonite rod when rubbed with wool is called a negative charge. Properties of electric charge. Unlike charges attract each other and like charges repel each other. Coulomb's law specifies the force of attraction or repulsion. It is impossible to build or eliminate a charge. Charge conservation. A charge is always expressed as an integral multiple of 1.6 multiplied by 10 to the power minus 19 C. A body becomes negatively charged when an electron is added, and positively charged when an electron is taken away. Proton and electron presence determines the charge on each atom. Proton does not take part in charging since it is tightly locked inside the nucleus. One electron or proton has a charge of 1.6 multiplied by 10 to the power of minus 19 C. The electron has a sign negative and the proton positive. The force between two charges varies directly as the product of two charges and inversely as the square of the distance, r, between both charges, q1 and q2. Therefore, F equals K multiplied by q1 multiplied by q2 divided by r2 as shown in the figure. SI. Unit of charge is Coulomb, C. 1 Coulomb equals 1 ampere multiplied by 1 second. That is, 1 C equals 1 M multiplied by 1s. Thus, the quantity of charge which flows through a circuit when 1 ampere of current flows through it in 1 second is known as a 1 Coulomb charge. What are the types of materials? Conductor. This is the material that can allow the flow of electrons through itself is called the conductor. It has a large number of free electrons. It offers low opposition in the flow of current. Insulator. The material that does not allow the flow of electrons through itself is called an insulator. It has less or no free electrons. It offers high opposition in the flow of current. What is electric current? The rate of flow of electric charge is known as electric current. Electric current is carried by moving electrons through a conductor. The amount of flow charge through any cross-sectional area of a conductor in unity time is called electric current. It is represented by the letter I. If a net electric charge, Q, flows through a cross-section of a conductor in time t, then, electric charge is equal to net charge divided by time, or I equals Q divided by T as shown in the diagram. Where I is the electric current, Q is a net charge and T is the time in seconds. Current comes under scalar quantities. Amperes is the SI. Unit of current. Current is defined as 1 ampere if 1 coulomb of charge passes across the cross-section in 1 second. The transferred charge is always an integral multiple of the primary charge of an electron. This characteristic is known as the quantization of charge. This means that Q equals N multiplied by E. Where N is the number of electrons and E equals 1.6 multiplied by 10 to the power minus 19 C. What is a small quantity of electric current? The small quantity of electric current is expressed in milliamperes and microamperes. 1 milliampere equals 10 to the power minus 3A. 1 microampere equals 10 to the power minus 6A. What is the electric potential difference? The electric potential difference between 2 points in an electric circuit carries some current as the work done to move a unit charge from one point to the other. Electric potential is the amount of effort required to move a single positive charge from infinity to a specific place. Depending on the type of charge at the location, the electric potential can be either positive or negative. The unit's positive charge is repelled by the point if it is positively charged, emerging from the limitless. Since the electric potential is positive, we must work to move the unit's positive charge to that location. When a point is negatively charged, it draws a positive charge from infinity itself and has a negative potential. Charge from greater potential flows to lower potential when two charged bodies are maintained. Positive ions and proton-like charges will flow from a higher potential to a lower potential if they are free to do so. Electric potential difference is denoted by V. Therefore, V equals W divided by Q, where W equals work done and Q equals charge. SI. Unit of electric potential difference is volt and denoted by V. This is named in honor of Italian physicist Alessandro Volta. There is another unit for volt, where volt equals joule divided by coulomb equals Jc to the power of -1. What is a voltmeter? It is an apparatus to measure the potential difference or electric potential difference between 2 points in an electric circuit. What is a galvanometer? It is a device to detect current in an electric circuit. Let's do a question. A current of 0.3 amp flows in a circuit. How long it takes to flow past 15 C of charge? Do pause the video and figure out the answer. Answer. I equals Q divided by T. 0.3 is equal to 15 divided by T. Then, T equals 15 divided by 0.3, which is equal to 50. Let's do another question. A steady current of 1A flows through a conductor. Calculate the number of electrons that flow through any section of a conductor in 1 second. Don't forget to pause the video. Answer. Current is said to be 1 if the rate of flow of charge through cross-section is 1 C per second. As the electrons are flowing from B to A, the conventional current direction is opposite to it, that is A to B. I equals Q divided by T, which can be written as NE divided by T or N equals I multiplied by T by E. Substituting the values, we get 1 multiplied by 1 divided by 1.6 multiplied by 10 to the power of -19, which is 6.25 multiplied by 10 to the power of 18. Let us now do a question on electric potential. The electric potential at two ends of a conductor is 10 V and 5 V. 5 J of work needs to be done to move a certain amount of charge from the end at the higher potential to the end at the lower potential. Find the amount of charge flowing between the two ends. The answer is potential difference equals V1 minus V2. Substituting the values, we get 10 minus 5, which is 5 volts. We know that V equals W divided by Q, which can be rewritten as Q equals W divided by V, which is 5 joules divided by 5 volts, which equals to 1 coulomb. That's it for today's video. In the next class, we will start by learning about Ohm's law. See you, and don't forget to subscribe. It's as fast as electrons traveling through a wire.